Hello and welcome to ELT Maestro tutorial. My name is Z and I will show you how to load data into Hadoop. There are basically two steps available, OnstageGroup and Jdbc Source target. OnstageGroup can load data for multiple tables using a single step. It can also export these files into Amazon S3 buckets. OnstageGroup can load delta, or the data that has changed on the source, incrementally into target. Jdbc source and target steps are designed to load very large tables, and they can extract and load data in parallel. Now, before we start, let me create two folders on Hadoop. For that, run the command hadoop fs-make directory and a folder name. I'm going to make two directories so that I can demonstrate OnstageGroup and Jdbc Source target steps. On the main window, let's create a workflow and call it OnStage Spark Load Test. Click OK. OK. Yes. I have an empty workflow here. Let's drag and drop OnstageGroup. Right-click Edit. On Source, let me select one of the connections. I'm going to select ABC. Browse to public schema, load partitions, say 2. I'm going to browse to dir1. Okay. So basically this is a schema level configuration. On Tables tab, I can select multiple tables. I'm going to add just these two tables here. Click refresh metadata so that these combo boxes are populated. Watermark, last updated time, keys, select the primary keys for these tables. What I did here is I want to load this table batch cycle run incrementally based on a column called last updated time, and so on. It's the same case for the other table as well. Click Save and run workflow. Run. When the workflow starts running, the checkbox here gets checked, which sets the workflow into logging mode. And you can see a busy icon here that indicates the workflow is running. I can also track the workflow by looking at last console output. Now this workflow has finished. I can look at the terminal output here, run history, or metrics, which tells me how many records were loaded. So 107 rows for batch cycle and 4200 for batch cycle run. If I go back to the designer and click this button here, it gives me more information about different files used, data frames being generated using Spark job. So this is how you can load multiple tables using OnstageGroup. Let me drag and drop a data frame object and browse to those paths. Browse dir1 batch cycle. I can see there's one Parquet file there. Columns are shown, preview, and then there is data. Let's try for another one, batch cycle run. Refresh, repopulates the metadata, preview, and there's data. So OnStage group step can be used to load multiple tables. If I try to rerun this job again, so on the second run, I should see less data being downloaded. When I click metrics, there was one row added since the last load, so it only downloaded one row. That cycle remained unchanged. Now let's create a job to load data in parallel. Call it Jdbc Spark load test. Click OK. Open the job. In this case, let's drag and drop two steps, Jdbc Source and Jdbc target HDFS. Same connection. This time we will load batch cycle run table into directory 2 folder. This step automatically guesses some key and partition columns. If you want to change that, you can change that here. The metadata button here gives you a list of all the columns and the columns by data types as well. Numeric columns here, key columns, primary, secondary, or index columns as well. So you can use these columns here. Now, I know that this table only has about 4,000-ish rows. I'm going to change the partition to 1,000 rows so that I can load them using 4 threads. Auto partitioning based on batch run num. Source SQL template, no changes. Partitioning reference is the same table. No changes on performance and quality or manual partitions. So here we will let Maestro decide how many partitions it creates, but I want to extract this table using 4 threads. Okay. Now, I did not specify the target here because this is a configuration for extractor. Connect that to target HDFS. Open this step. Type in /dir2. dir2 is empty. Let's say I want to have 4 loader threads. Let's map the columns. On source, refresh. ELT Maestro automatically converts the data types into Spark data types. Mapping columns, reset. Okay. Watermark. Not much change here. Okay. Now, check mapping. There are no errors. We're ready to run this job. Click the Run Workflow button. Okay, run. This job is finished. Metrics. Refresh. Not much here. Vertical metrics shows detail level metrics like row counts. These are the threads. There are about 7 extractor threads. Out of them, 4 or 5 are running in parallel. We're running in parallel. The way to tell that is if we look at last console output and scroll down somewhere over here, when Maestro does a data profiling, it generates partitions based on the partition column. So the minimum value and maximum value is considered when calculating the range or width buckets of the rows, and partitions are calculated for chunks of 1,000 rows. In this case, Maestro decided to use 536. So maximum of 1,000 rows is used. When the data is skewed, you don't always get exactly same number of rows in a partition. Now let's take a quick peek at the data that's loaded. My target is dir2. On the data frame object, specify the path, click refresh, preview, and I have data. So the Jdbc Source target loads a single table in parallel, whereas OnstageGroup loads multiple tables in sequential. If I rerun this job again, let me see if I have a watermark or delta column specified. I'm going to change this to batch run num, click OK, and run it. So what this does is the delta piece gets a max value of batch run num from target, in this case Hadoop, uses that value to generate our query to extract the data that is greater than that run number. As you can see on the log, the delta condition here is where batch run num greater than 9545. If I look at vertical metrics and refresh, I only see one row. This is because the first job that we ran added a record on the table batch cycle run, and this job loaded that row into target. Thank you. If you need any help, email us at zdave@maestro-analytics.com.